Welcome back. Today's lesson is on biofuels. By definition, a biofuel is an energy source that is made up of at least 80% of recently living biomass. So what we're talking about are plant material or biomass that is turned into a fuel. So you have many different choices, as you're going to see throughout this entire lecture, about the different possibilities of making different types of plants into a fuel source. There's been an increased, renewed interest in biofuels. Initially, there was an interest, but more recently, over the past decade, there has been a lot of development in the biofuel industry, mostly because of rising oil prices, so that the biofuels can become competitive and be created as an alternative. Also, the idea of climate change and greenhouse gas emissions from oil and coal and natural gas. All right, and the other thing is something that you might not think about so much. It's because it's more of a social issue, and that is the rural development. So in other words, these farm communities now have a better chance of making money using biofuels or using their crops as biofuels. And this is just something I had to show you because I think it points out that exact situation. These are all the ethanol biorefineries that we have in the United States. And if you look very closely, or it's quite obvious, you see most of them in this location, centering on this particular state, which is Iowa. And just a coincidence maybe, but I doubt it. Iowa is real big, obviously, in farming, and the farmers are looking to increase, their profits and be able to sustain their way of life. And it just so happens that in America, every single one of our presidential elections starts in Iowa. And so I think if you want to become president, you try to win in Iowa, where you have a huge biofuel industry. And so just about every single presidential candidate that I know of has supported biofuels. And you'll find out that today the subsidies for biofuels is tremendous. All right. In fact, it is the highest amount of money subsidized by our government for any particular fuel source. Ethanol, which is what you're going to find out is the biofuel made out of corn in the United States, gets most of the money from our government. Our federal subsidies, the money that's given out to the industries, most of it goes to ethanol, second only to oil and gas. All right, and coming in third would be the coal industry, with all the rest far behind. So you can see that of all of the renewables, it looks like we are focusing mostly on ethanol. So it's going to be part of our fuel economy for a while, and we're going to take a look at whether that's a good thing or a bad thing, as we want to find out. So let's take a look at the different types of biofuels. The first we're going to talk about is biogas. All right, this is when you take organic waste, such as manure, sewage, all right, and break it down anaerobically. Okay, landfills do this. Okay, but if we can do it on a large scale using animal waste or human waste, then we can produce a large amount of biogas, which is mostly methane, which then can be burned and used as a fuel. So we have that tremendous potential here that farmers can use it. There's a tremendous potential for biogas for farms. Okay, because all animals produce biogas in some way. But the way you do it is you create a biogas generator, which is very simply pretty much like a storage container underground. Okay, and what the farmer will do is he'll add the waste, usually cow manure or something like that, and you create a huge, literally, tank full of waste. All right, prevent oxygen from getting in there. You get anaerobic decomposition. That anaerobic decomposition bubbles up the gas. All right, and that gas then starts to form at the top, where you can then pump it out, because most of this gas will be methane. You'll be able to take it to your house, just like natural gas, since natural gas also is mostly methane. You'll be able to take it directly to your house or to your business, and you'll be able to burn it for heat or to produce electricity. So it's a type of biofuel, in this case in the form of animal waste turned into gas through anaerobic decomposition. So you have that potential. Second type is bioethanol, or what we call ethanol, to be a more common term that we use that. Ethanol, all right, is the most common type of biofuel around. It says especially in the country of Brazil, because Brazil is 100% non-oil. They went completely to ethanol, and they use ethanol through fermentation of the sugar from sugar cane. Okay, in the United States, we get our sugar for the fermentation process to create ethanol from corn, mostly. All right, and so basically, it's produced when you can take the substance, break apart the sugars and the fats, take the sugar. It's the sugars, and take them and go through the fermentation process. The sugars then create kind of like an alcohol, and that alcohol then is known as ethanol, which then burns. Okay. One of the concerns with ethanol, which is a big concern of mine and many other people, is that we are taking farmland that's used to produce corn, that's used for food, and turning it into a fuel. Okay, so to counteract that, scientists are looking into a new type called cellulosic ethanol. And cellulosic ethanol is using any type of plant material. It could be the corn husks rather than the corn itself, or it could be waste product even from like a house that you tore down and you had the wood left over. Okay, this is a far more complicated process, a little more expensive process, but it also produces more energy in the long run. So, and it doesn't, you don't have to worry about the food or fuel controversy. So cellulosic is a great alternative. And one of the problems with ethanol is that it has a less BTU value, all right, than gasoline, that where you would use it. So ethanol sometimes is not as powerful and long-lasting as gasoline is in a car. But it is an alternative, and we're looking into it, producing it. Okay, so it has tremendous disadvantages, which I don't know if you think will outweigh or not outweigh the advantages of using this as an alternative to oil, let's say. One of the problems is we just don't have enough corn in the United States. We just use so much oil in this country. If we took all corn production that we have today and converted it into ethanol, and ethanol only, it would still only make up about 20% of our total oil consumption. If we replaced our gasoline engines with ethanol, it would still only be 20%. All right, that's only 30 billion gallons that we're possibly able to create a year out of the 146 billion that we use. So we're talking about a very limited proportion of our oil use here, even if we did turn all of our fields to ethanol production. The other problem is that it has a low energy value, okay, or energy yield. The net energy yield of ethanol is about 1.34. Now what that means is for every 1 unit of energy you put into it, all right, you get 1.34 units of energy out of it. So it takes energy to produce the corn, it takes energy to take the corn and ferment it and pull out the sugars, it takes energy to transport that. Out of all the energy spent in creating the fuel, for every unit of energy spent, you're going to get 1.34 units out. And that is not a tremendous number. Okay, it's not a terrible number, but it's just not a really good number. You'll see that there's others that can produce more than that. And of course, the other disadvantage is you get lower miles per gallon. The food for fuel or food for people controversy, we're still there. And the conversion of land use. In the United States, it could be turning our prairies and some of our native lands into production for corn, for ethanol. In Brazil, it's taking the rainforest, cutting it down, and turning it into sugar fields to create the sugar cane to produce the sugar for their ethanol. So Brazil is very proud that it's oil-free, but at the same time, the conversion of their rainforest into farm fields is an issue that alarms environmentalists. So you have the value that you get out of getting rid of the oil, but at the same time, is that offset completely by the disadvantage of cutting down the rainforests? So let's go to another type of fuel. Okay, instead of ethanol, let's go into something called biodiesel. Okay, what is biodiesel? Biodiesel is a renewable fuel that's created for diesel engines, which is slightly different than our oil or gas engines. Okay, but in this case, it's made from natural oils. In the United States, we like to use soybean oil, or there's many different types, canola oils, or it can be used on a small scale even from grease and waste products like that. So it comes from natural oils mostly. Okay, and it is blended usually with regular diesel fuel, and you can use it to provide power for diesel engine cars. So it has some potential. It has some great positives to it. Okay, it's made from oil and fats and greases. Okay, from vegetable oils as well. Biodiesel can be used in the pure form or blended. All right, and in the United States, 80% of our commercial trucks and buses run on the diesel. So there's a market for this. And we have the ability to produce a lot of this for a very good reason, in that commercial buses and trucks and things like that run on diesel rather than regular gasoline. So here's one of the great benefits too. You take a renewable resource, plants like canola, okay, you turn it through, well, one, you can pull out the product, the food product, and use that, so you have that advantage. Then you go through the biodiesel production. You get rid of the glycerin out of the plant, which can be used to make soaps, by the way, so you're not wasting that either. And then you turn it into a renewable fuel, which when burned gives off carbon dioxide, but that carbon dioxide can be absorbed by the plants that you're then planting to replace the ones you just used to create the fuel. So you can cut back on greenhouse gas emissions. So you're reusing that. Great idea. Possibly. Okay, you can make it on a small scale, and that means like cooking waste, like greases or vegetable oils. People can make it at home, and you can use it in your diesel-powered cars if you have a diesel car. On a large scale, again, soybeans are the most common, but you can make any type of most type of vegetables into this fuel. Here's a small scale, right in your garage, making biodiesel, and there it is on a large scale. It has some advantages. It's safe, it's biodegradable, okay, less air pollution. It still produces small amounts of air pollution, but it's much significantly less than if you used oil or diesel. Your greenhouse gas emissions are reduced if you go to just pure blend of biodiesel. You're talking about 75% reduction in the greenhouse gas emissions. You can make it here in this country. It's a direct replacement. You have very little that you have to do to any diesel engine car to use it. It does provide, again, local development. Okay, it has greater energy benefit. You get a net energy of about 3.24, which is much better than the ethanol. All right, and like I said, the existing fuel equipment, even the gas stations and pumps and stuff like that, can be used. So it has some tremendous advantages, but it also has some disadvantages. That is that it's more expensive. It doesn't have the availability. It's not nowhere near as abundant as oil and gasoline. It has a problem, believe it or not, that it dissolves the sludge in the tanks and filters in your automobile, which causes a problem in your car. So they have to consider that when using biodiesel. Your fuel economy isn't quite as good, so you're filling up more often. Okay, you have problems in cold weather if it's for cars, but again, you're back to the same two problems that you had with ethanol. Food for cars instead of people again, because you can't always turn this stuff back into food. Sometimes you can, most of the time you can't, depending on what source you're using. And should we be converting natural lands to produce more of these plants that produce the oils that we want to use for biodiesel? Questions and disadvantages that arise almost at every biofuel. But now we have a new type. It's more in the experimental stage, but we're starting to produce it in larger quantities, which has tremendous potential, and that's algae biodiesel. So instead of using one of the oils or greases or anything like that, or vegetable oils, we can use algae. So you lose that food for, fuel or food controversy. Okay, you have tremendous net energy, and you actually have a negative carbon ratio of carbon dioxide being put in the atmosphere. So we can actually call it carbon sequestration, which you learned back when we talked about coal, where you put carbon dioxide back into the earth in some way. In this case, the algae would be absorbing that carbon dioxide in huge numbers. All right, and these are the biotubes that have the algae in them. This is the process by which the algae is turned into the fuel, where the algae starts. If we go over here real quick, I'll go through this with you. You grow the algae. You start by growing the algae, and then you basically take away the nutrients for the algae, and they call it starving of nutrients. And what that does is it doesn't really cause the algae to explode like you see here, but it does cause the algae to break down. And when it breaks down, it releases its fats and sugars. Okay. Then you use a solvent to separate those, pull out the to separate those, you evaporate the solvent out. Okay, and then you take the fats and make it into biodiesel. Okay, so here's a great way of taking algae and making biodiesel out of it, and it has tremendous potential, absolutely tremendous potential. So now you're going to have these bioponds start to show up, where it literally is just cultivating algae in the ponds, or you can use these tubes, these upright tubes, where the sun now has the ability to hit more of the algae, because in a pond you're only going to be able to go down a certain depth when the algae won't have any more sun. If you put it up on stands like this up high, you can have a lot more algae and put it into a whole entire field where you just have tons and tons and tons of these things, and you can start producing biodiesel on a large scale. Why are we so big on this algae idea? Well, take a look at this chart. These are the gallons of oil equivalent. All right, the gallons of oil equivalent per acre of the crop. If you look at corn to make ethanol, you're talking about 15 gallons of oil equivalent per acre. Soybeans and these would be your biodiesels. Okay, you can see they're equivalent per acre, better than ethanol. But look at algae. All right, potentially 10 to 100 times better than the best plant. So here we finally have potential. Unfortunately, the research still needs to be done. There's still more work needs to be done. It's not quite ready yet, but it's getting there. Maybe we could use that as an alternative. So algae has tremendous potential. All right, so let's look at where we stand right now. Okay, biofuels that are made from sugars and starches, known as the first generation, would be like your ethanol. Okay, then second generation biofuels are the ones that are still being developed, where you take it to the next step, where you can use waste products like cellulose or cellulosic ethanol. And if you look at this chart, it starts off with gasoline here, then biodiesel, which just talked about, corn-derived ethanol, and then the other type, cellulosic ethanol. Okay, and just real quick, the net energy balance or yield, you're talking 3.2 for biodiesel, approximately what I gave you before. Unfortunately, for ethanol, it's much lower, and cellulosic, it's kind of in the middle, but it's still very, very good. Okay, greenhouse gas reductions, just look at the differences here. Again, we're talking cellulosic. All right, costs not too important. Gallons per acre, again, depending on what type you use for biodiesel. All right, ethanol, you can get a lot of ethanol per acre, but the equivalent is not as high when you talk about gas. But look at this. You can get a huge amount of cellulosic ethanol. So when we talk about biofuels, we can talk about biodiesel. Right now, the algae is not on this chart because it's just not available right now. It's not ready yet, so we couldn't put that on this chart. But the biodiesel has a tremendous ability to provide some fuel. Ethanol, I would call it the weakest of the three, and then cellulosic is the big one as an alternative now, I'm saying, to gasoline in the first column there. Okay. How important is this to the United States? Well, just take a look. This is in King of Prussia. The agricultural secretary made an announcement to provide $25 million more funding for research and development of the next generation of bio-based products. And I just think this is important to just read real quickly. It says, the United States Department of Agriculture's continuing investments in research and development are providing a critical piece of President Obama's strategy to spur innovation of clean bioenergy right here at home and reduce our dependence on foreign oil, said Vilsack. The advances made through this research will help to boost the local economies throughout the rural America, creating and sustaining good-paying jobs while moving our nation towards a clean energy economy. And this was all part of the 2008 Farm Bill, where they're providing funding for new bioenergies and just some of the projects that were just awarded recently. The first one, and again, these are just more for your information. You will not have to be responsible for these on a test or a quiz or anything. But in this case, you're talking about an oilseed crop possibly being a good alternative. All right, here you're talking for Ohio State, where you're talking about anaerobic digestion. Okay, down here in Salt Lake City, here you got creating animal feed, but also biopower from a new hybrid. Okay, and then also you go all the way down to the bottom, and this would be converting forest residues after cutting down forests, the leftover pieces from like the trees when they cut off the branches and stuff, or maybe horse manure or switchgrass into biofuels. So you have tremendous amount of research going into this right now. Like I said, the subsidies are there for the biofuel industry. And it's hard at work, so that maybe someday we'll be driving in our biofuel cars. Although that's not quite what you would be driving. This is more what you would be driving. Okay, and if it's a biofuel that says E85, that means 85% ethanol. Like this one, this would be bioethanol. Okay, from Ford. So maybe someday we'll be there. So in general, let's think about this. What type of biofuel do you think is the most promising to solve the United States energy problems, if any? How about, what are your thoughts about using food crops as a fuel? Okay, and what ripple effect would this have on consumers? All right, which is very important for us to think about. And do you think the positive impacts of biofuels outweigh the negatives? Are they really worth pursuing? And these are questions that you have to answer. So, environmental science can give you so much information. It gives you the knowledge to actually consider these. It's now up to you as a informed citizen to make that choice. And hopefully the information that we provide you will give you the background you need to make the right choices in the future. So just keep it in mind. This is a shout out to my one class. You know who you are, and you know why it's there.